Yeah, so thanks to the folks from ResMed and SRC. I know, someone actually has to go through the work and typically be here and open up and close down and do the logistics for the food and all of that. So having done that at Sun for the OC jug and the LA jug, I know that it takes work. So I guess as a speaker, I appreciate that. Okay, voice check. Can everyone hear me? Yes. Can you hear me when I'm talking this way? Testing 1, 2. Okay. Okay. Sorry. A lot of times when you buy a TV, they talk about viewing angle, but they never talk about audio angle. So I just kind of need to know where I need to point. All right. So the topic is Java Enterprise Edition 8, or Java EE 8 for short. And sorry, I move around a bit, so I'm not sure from a camera guy perspective if that's good or a bad thing. I'm not all that much to look at anyway. So, let's see. This is a slide deck I actually stole from Linda D. McHale. She's one of the Java EE platform leads, and then I kind of hacked it a bit. But this was a lot of the content came from a Java day in Japan last month. Let's see here. Safe harbor statement. From a product, there's nothing here that we're trying to sell, right? But typically Oracle has a safe harbor statement that says don't make business decisions about anything that I talk about. And it doesn't really apply here, but this is kind of a mental cue for me to say that with Java EE 8, it's still being defined, right? That means any code examples I give can completely change, right? The expert groups are working on the APIs, they're working on, in some cases, they have the scope defined, but to meet dates and so on, they may have to cut scope. So some of the features that I talk about here, there's a small chance they might not actually show up in the actual platform, right? So just kind of a little bit of a heads up on that. So again, I'm going to talk about a little bit of a EE7 review, and then get into EE 8. So I have a question. Since I'm the product manager, I love to ask this question. How many, or is there anyone in here that wants to take a crack at explaining the difference between J2EE, Java EE, and JEE? And not incur my wrath.
Never mind that.
Okay, first of all, there is no such thing as JEE, right? A lot of people say JEE, right? Okay, come on. Before the meeting, before I mention this, how many actually refer to it as JEE? Wrath.
Yeah, so as a recruiter, you use all 3 of them because people use all of them in their resume.
Yeah, and it's funny because last year, and you're going to see a slide where I talk about career opportunity and stuff, and I went, and when I had to search the job boards, I was trying to get a number, right? There's like over 30,000 jobs, I think, that are Java EE and, J2EE and JEE related. So I understand your point. What just drives me nuts as a product manager when I have to go in and I look at these things and I see that these terms are being used, right? There is no such thing as JEE. It's made up, and people just tend to, shorten it. Okay. J2EE. It ended in 2006 with the introduction of Java EE 5, right? It was J2EE 1.4, and then it became Java EE. And a lot of things changed, I think, from an API approach perspective to Java EE 5. It's more POJO oriented. And so on. But is anyone here still using the J2EE app server? Going way back to 2000. Oh God, I'm so sorry. Okay, there's typically one, right? We rarely ever more than one. And I'm sorry to hear about that. And so basically, it's Java EE. It's the enterprise Java standard, right? As defined by the JCP, the Java Community Process. All right. So this is a slide that was put together for the Java 1 keynote, strategy keynote, and that's one of these are slides that I actually work on as a product manager. So career opportunity is an example of where all those terms that I use. But there's still, there's like 30,000 plus jobs as of Java 1. I went out and searched recently for enterprise Java, right? Tons of books. I kind of stopped counting. It's probably in speaker notes, but I think we were somewhere around 35 or 40 Java EE books. on the market. There's a ton of compatible application servers and an awful lot of Java user groups out there that do that talk about Java EE. And there is one kind of action item I have at the end of this presentation that I kind of want to talk to the group about. So Java EE is a continuum, right? We started out with Java, well, J2 EE, back around 1999 or 2000 with one, and now we're basically heading toward Java EE8, right? And even though we released Java EE7 in 2013, and now I'm talking to you about Java EE8, it's a continuum, right? It's a continuum in terms of the specs are getting tweaked a little bit in some rare cases. In fact, let me give you some examples here. So since the announcement, we now have 4 Java EE7 compatible application servers, right? And I suspect that Java 1 this year, you're going to see more Java EE7 application servers. So the application server implementations always trail the standard, and it's a pretty feature-rich standard. So the day the standard is kind of ratified is when GlassFish is announced at the same time. It's the first implementation because it's really the foundation for the reference implementation for Java EE. Right? Anytime you have a spec for going for the JCP, you have to have an implementation of it as well. And for GlassFish is the reference implementation for Java EE. And then the others tend to follow. Wildfly was shortly next. Actually, no, sorry, T-Max then Wildfly, and Hitachi Cloud Nexus out of Japan. They're actually the first commercial implementation where they can actually go out and buy and get support for. And the specs have gone through some, fine tuning. As vendors implement the specs in their application servers, sometimes some things are a little bit fuzzy, and they go back to the spec leads and say, hey, either it's kind of a gray area. Can you clarify it, or can you add this, in the case of the WebSockets, lambdas weren't working in a particular API in the message handler. So we actually had to go back and add a method call so that lambdas would work, right? Where you can specify the type. So there are, Java EE continues a little bit, EE7, but in a very, minuscule kind of way. Java EE learning path. So there are Java certifications that, Sun had certification courses prior, and now Oracle has Java certification courses, where you get a certificate saying, I'm an Oracle, from an Oracle perspective, a certified Java programmer. And we have EE courses as well. So if you go online, there's kind of this EE7 new features course, or actually it's video. I think it's half hour long. That's free. And then there's going to be courses that you can take and certifications around these areas, right? So the first one that's going to be available, it's already up on Oracle University, the EE7 front-end web application development course, right? So we've really, from a certification perspective, kind of consolidated a little bit around the types of certifications that we develop. There'll be a front-end developer, a back-end developer, and then an architect course. Okay. All right, so Java EE8. And by the way, I'm not sure if this presentation is going to go until 9 o'clock. For some reason, none of my presentations are supposed to, but I seem to consume all available time. So we'll see if that happens again here. Any questions on EE7 before I move on to EE8? Okay. Out of curiosity, now before I continue, how many here are actually developing to Java EE using an application server, or let's start there, like an EE application server? Raise your hand. One. Okay, you kind of raised your hand on J2 EE. Okay, how many are doing a servlet container type approach? Okay, yeah, a lot more. Okay. And let's see here. So when it came to figuring out what we wanted in Java EE8, the first thing we do is we look at industry trends. And who is we? Initially, just the group of folks at Oracle who are kind of responsible for Java EE, myself included. But this is just a very vague first step, right? And this is what we did going into Java 1 I think 2013 when we announced Java EE 7 more or less, and we were thinking about what's going to be in Java EE 8. We kind of look at trends, and you can see obviously HTML5 and cloud are really big, and mobile and so on. But a lot of these, but we also did a lot of requirements around from other expert group members, from other vendors, from the community, right? It's actually much more involved than you might think in terms of how do we decide what features are going to be in Java EE, right? Probably, let's see here. Let's see, user lists. Oh, Jira bugs. We also go to Jira. It's a surprisingly rich. It's a surprising place to go where you see not just bugs but RFEs, right? A rich set of RFEs. A lot of people vote on these RFEs, right, using the vote feature, and that also becomes input into Java EE. And then we have some evangelists. Some of you may know Reza Rahman, and then David Elbasi is in Europe. And they speak at a ton of conferences, and they get feedback from a ton of developers. And probably the thing that had the most impact is actually a community survey. So based on a lot of these sources of input, we kind of created this survey that took a lot of this input, and we were trying to figure out what we wanted to see in Java EE. So it was a 3-part questionnaire delivered from late 2013 through early 2014. We had a ton of questions, some where you could fill in the blanks, and we had thousands of comments from those fill in the blanks. You'd be surprised at how many we actually got. And we had over 4,500 responses to the survey, right, which is a lot of really good data. It's probably the largest set of concrete data that we had. So based on that, we took the features that were requested the most. And there's always more that people want than you can actually deliver in a version of Java EE. And we said, here's $100 virtual dollars, spend it on the features that you want the most, right? That was the third survey. And they basically spent that virtual money, and that's how we came up with these set of features. By far, what people wanted the most was a JSON binding API. So in Java EE 7, we introduced JSON processing, right? But there was no way to actually take JSON and bind it automatically to a Java object, kind of like you do with JXP and XML. That was the biggest requested feature. Security. People really wanted to see a lot of work around security in Java EE, so I'll cover that more. And then it goes all the way around the pie chart here down to pruning, right? Very few people are going to say, here's some money, take away these features, right? So it didn't get a lot of votes, but it's still something that we're very focused on, because if there's features in Java EE that really no one uses anymore because they've been supplanted by newer technologies, like the old EJBs are now being replaced by EJB 3 and beyond. We kind of started pruning some of that out, right? So that means vendors also don't have to implement them, right? Which reduces the cost of the implementations, and makes them smaller and so on. All right. So what we did is we took those 3 features and kind of formed themes around them, and these are the 3 things I'll be talking about. HTML5, ease of development, and those are 2 features that were in EE 7. Right, and they're still really hot technologies or areas of interest, and so we're going to kind of keep those things. And let's see, ease of development has been a focus since Java EE 5, right, the first EE release, and that's why I mentioned that there's not only did the name change from J2EE to Java EE in 2006, the focus really changed on developer ease of use. That's why in Java EE, you see us moving more and more towards a POJO-oriented development model, where you just, if you want a certain feature, you kind of apply a Java annotation to it. Not true in all cases, but in a lot of cases. Oh, and the third is infrastructure oriented. Right? I'll be talking about that. All right, kind of a menu here of things we'll be talking about in terms of HTML5 and web tier. JSON binding. So I mentioned that we've had JAX-B that lets you bind Java objects, or map, I guess, Java objects to their XML representations and also do binding. That's missing right now from Java EE. And so we knew that going into Java EE 7 even, but the first step is to create the processing API, the low-level API that does all kind of the work in terms of processing the XML, kind of like JAX-P. And then on top of that, we have now in EE8, the binding API. That will probably just leverage the processing API underneath to actually do the processing, and then the JAX-B will actually bind them to the Java objects. And what you'll see is, you can just really not have to do anything and just say marshal or unmarshal, but you can customize how you want the marshaling to happen using, again, annotations. So you could say, make this field transient. In other words, don't marshal in either direction. Or you could say, the name of the property is maybe first name, but maybe in your JSON you want it to be name, right? So you'll have ways to customize your binding. And there's a ton of implementations out there that already do binding, right? And Jackson is probably what most people use, but I think for JAX-P, there were 17 not JAX-P, I apologize. For JSON processing, when we kind of started doing it for EE7, there were 17 implementations of a JSON parser available, right? Which means there's 17 different APIs that you could choose from. And if you wanted to switch from one implementation to another, you would have to basically rewrite code. And so that was the value of JSON processing, is now you can write your code once and just under the hood swap out the implementation. JSON binding is basically the same value prop, right? There's a ton of JSON binding implementations out there. Jackson, UC Jensen, and Moxie is actually developed in the EclipseLink community. It also does JSON binding. And so the idea behind the binding API is, again, you write your code once and you can switch out the implementation underneath, right? Okay. So here's a really simple example. This is a JPA entity. It basically has a name, a gender, and a list of phone numbers. Right. And what's interesting about binding is we want to make it pretty transparent or very easy to take your the data that you pull out of databases and have them basically presented out via JAX-RS to your clients, right, in their JSON representations. So in this case, I'm going to use JSON-B, but you can take any Java object, right, and marshal it to JSON if you want to, right? What you see here is we're basically just saying, create a JSON context, which basically is the wrapper around the implementation under the hoods, the binding implementation. Create a marshaller. In this case, we also set an option to make it pretty print on the output. And then on the next slide, go ahead and marshal the Duke object to standard out, right? And what you'll see is, something like that. All right, so from an API perspective, what they're looking at is pretty simple stuff, right? There's not a lot that you as a developer have to do for an object. Although I'm sure in the real world it'll be a little bit tougher than that as you deal with, again, you can customize how you want the marshaling to happen, effectively representing your data model and the limited data types of JSON, right? So pragmatically it might be a little harder, but from an API perspective, it's actually pretty simple. But that's not really the fault of Java per se, it's really JSON itself and the complexity of the business problems we have to deal with. So again, really we want to take JSON all the way from the data source, for example, the database, and push it all the way out to the browser. And I'll talk a little bit about JAX-RS and JSON binding as well. All right, so JSON processing 1.0 we released in Java EE 7, and we basically want to keep JSON processing up to date. So there's been some things happening. A couple new standards that we want to implement. And they introduce some interesting complexities that I'll talk about here in a second. And we also want to add some Java SE8 APIs to the JSON Processing JSR. So one of the things that happened, right, is Java SE8. How many of you have actually been using JDK8 now? How many of you have moved to JDK8? 1, 2 people in the whole 3, 4? Okay. And JDK8 adds, some pretty powerful features around streams and lambdas, right? And that's what people typically think of when they think of JDK8. Well, each JSR, so each one of these features that I'm going to talk about are going to look at JDK8, since that's the minimum required JDK for Java EE8, and determine if they think there's things they can do to make developers more productive by using those JDK8 features in the Java EE APIs. And this is one of those cases, right, where they want to basically create some new APIs that are focused on Java SE8 features. So the first standard is something called JSON pointer. And the idea behind JSON pointer is I can, given a path, specify in a JSON representation, which could be a pretty complex structure, point to a specific attribute somewhere in that structure, right, or element. So here's an example using JSON-P. I can create a JSON array. Again, this is a low-level API, not the binding API. So what you have is an array of contacts, and you basically, it's just creating a JSON representation that looks like this, right? So each call actually maps over to what you see in the JSON representation. So on the left is what's going to show up in the Java objects, and the right is what's going to show up in the JSON. Right? So now the question is, what if I want to point to just the mobile phone number that you see there? So what we do is we create a JSON pointer, right? It basically says, here's a JSON pointer P, and here's the path to the thing I want to pull out of this JSON representation, right? In this case, what it's saying is 0 is index 0 into the array, so it's the first, basically. I want the first objects in the array, phones and mobile. So I want the first mobile phone number, right? So that's pretty much that. Right? So that's pretty simple. This one's a little bit tougher though. So there's JSON patch. And the idea behind JSON patch is you want to basically manipulate your JSON structure, right? So that means that operations like you can see here, replace, remove, there's a copy, move, there's like an add as well, I can't remember what, I don't think it's called that though. But a series of operations that you can apply to a JSON structure, right? And the way it's represented in the RFC is basically the operation, the path, and then in this case the value that you want to change that object to, right? Or in the case of remove, right? You just basically remove the object in this case at the first position in the array, which is really the second position in the array.
Is this kind of starting to treat JSON objects like a database now?
Is this like creating? Let's see. Is this like creating a JSON representation like a database? And I don't know for sure, but I suspect that some of the NoSQL databases might be able to take a look at this and apply it to representations in their database. Except, what was that?
It's more true.
Yeah, but so are the representations that you can stick in, a Mongo or something like that, right? So, what I wouldn't know is how you deal with keys, right? How you find the right thing in the database, because this is talking about an array, unless it treats the whole database as an array. Anyway, but that's an interesting point. But really the idea is, when you're dealing with really big representations, of, let me phrase this. If you have JSON that can be really large, right? And you don't want to have to manually, as you're streaming, go through and figure out what I'm going to change and do it in a very laborious way. This lets you basically point directly to the JSON element that you're interested in manipulating, right? So it's actually, I think, a pretty good thing, although there is a challenge I'm going to talk about in a second. So here's those operations that you saw on the previous slide, replace and remove, and then on the right-hand side you see kind of the canonical example that we're using in this slide deck, where we basically have name, gender, and a list of phones, right? And in the first one, we want to basically replace the mobile phone number of the first person in the array. And so what you'll see, and I don't know if you can see, it might be hard to tell, but over here we have, it's now in blue, but we've applied the new phone number, right? Kind of pretty simple stuff. And in the second one, again, it might be hard to tell. It's now blue, the operation is removed, so that's the one we executed and removed that element from the array, right? Now comes the challenge. If you look at the JSON Processing API, it assumes that assumes that the JSON objects and JSON arrays in memory are immutable, right? And obviously this is not immutable. So they're trying to figure out how to modify the programming model to deal with mutability, right? So you can see there's one example where someone said, let's use a builder pattern. I think this is the spec lead. So let's use a builder pattern to create a mutable object and then basically convert to an immutable object after the fact. So for the rest of the API, you're still dealing with immutable objects, right? They haven't figured that out yet, but so this is going to be an area that's going to change. Okay. And the other thing that's interesting is, when you have JSON, you can have an array of many objects. It's just like a collection in Java, right? It's just in a different representation. So what we can do then is apply the streams and lambdas that we have in GDK8 to that collection per se. So in this case, what you're seeing is we have a list of contacts. You can think of it as that array, that JSON array that we've been working with. And we're saying, get the guys as a list of JSON objects, then filter out all the females and get the name, and then collect those into a list, right? So this stream, instead of lambdas, is basically return the names of all the females into a list, right? And to take it a step further, we may want to keep the representations in JSON, right? So what you saw before is we took something that was really JSON objects and converted it to a Java construct. And here what we're saying is, let's instead use the JSON. I should have brought my laser pointer. I'm not tall enough. Got a ladder. So JSON collectors. So basically now what you can do is take your JSON representations, apply lambdas on them in the streams API to collect them into JSON arrays. So you keep everything in the JSON world. All right. The next thing that we had in the web, the HTML5 web development kind of theme is server-sent events, and this is something that's in the in the HTML5 standard, and it basically provides a set of streaming text from the server down to the client, right? So the client connects, and basically the server can keep pushing down textual events down to the client, right? The canonical example is a stock ticker, right? The client just listening, getting all the new stock prices, right? And these are usually long-lived HTTP connections, and it's one way, right? So the server pushes it down to the client.
Is it 2 websites?
Sorry?
Is it through web?
Is it through WebSockets? It is not through WebSockets, it's just over HTTP, right? Even though WebSockets begin as an HTTP connection, these are standard HTML5 server-sent events, right? So from a server-side programming model, you still have all the JAX-RS HTML5 kind of verbs available to you, right? So this server-sent events are actually being rolled into the JAX-RS API. Right, and I think you see that in an example here. So we did look at, by the way, the servlet API, WebSockets, JAX-RS to figure out where should server-sent events go. And basically, JAX-RS seemed like the most natural fit. The streaming of HTML, the streaming of HTTP resources is already supported in JAX-RS. We have a very small amount of work that we have to do with JAX-RS to actually support its server-sent events. Jersey, which is the reference implementation that Oracle has, that's included in like GlassFish, for example, it already supports server-sent events. So we have a reference implementation that we can kind of use as the foundation for where maybe a good starting point. And I think REST Easy also supports server-sent events, right? So we have some starting points. Let's see. So this is a really simple example where we're using the canonical example of stock data, right? And you'll see that we have your typical JAX-RS class where we have where we apply GET to the method. That's going to receive the HTTP GET request. But you'll notice that under produces, we're now producing text/event stream as the media type for server-sent events, right? So the method that's going to get called is GET quotes. It's returning a new class called event output, right? So the event output is basically the class that is going to, it's going to encapsulate what's going to be sent back to the client. And what we're going to do in this case is we're going to create this stock thread that uses this event output to push down stock prices down to the client. And this is your typical Java thread. And I've asked Merrick, he's the spec lead for this. We need a different example from stock instead of using threads, because you're not supposed to use threads in Java EE. Right? It's kind of one of the same thing to do. But that aside, what we're doing here, if you look in the threads run method, what we're doing is we're just sending down a set of stock quotes, right? Every whatever, right? Every minute or whatever there's an update, you can send down a new stock quote. And you just call in the event output on the event output object, you just call it instead, right? You're just sending whatever the object is. And it'll get converted to the representation that you want using whatever JAX-RS provider you have that knows the type. In Java EE7, we added a native client API. So typically, most of you are going to write web-based clients, right, that connect to a server and get server-sent events down through a web browser. But we also have in Java EE7 a Java client for JAX-RS. And basically, we added client support for server-sent events as well, and that's using the event source class. So basically, all you have to do is just override on event, and then you use on the event you just read the stock class, and you get the stock class in the client. Right. So it's a pretty simple API. And again, a lot of it's because most of the work was already there in JAX-RS. Okay, this one to me, personally, was a little bit controversial because when we were trying to decide what question should we ask in this survey, MVC came up, and we're like, does anyone do MVC anymore? I thought everyone was doing HTML5 and single-page applications and that kind of stuff. And well, I'm glad we asked because it came back pretty high in terms of what people really wanted in Java EE. So there's basically two styles of MVC. There's your component-based MVC, where the framework itself acts as the controller in the MVC, right? And Java Server Faces is a very good example. And then you have the action-based MVC, right, where it's up to you, the developer, to write the controller. And examples, right, Spring MVC. How many Spring developers here? Okay. So Spring MVC, Struts 2 are some, pretty well-known examples of an action-based MVC. And developers basically wanted a standard way of doing MVC on Java EE. So Struts is kind of getting old, it's a little bit venerable. And if you're, we had some Java EE developers that didn't want to do Spring, but they wanted to do Spring MVC, right? Well, now they have an MVC in Java EE. Not to knock Spring at all, right? It's just the programming models are a little bit different. So basically, with MVC 1.0, what we're really trying to do is we're trying to glue together, it acts as its glue for a lot of the technologies that already exist in Java EE, right? Okay. So with the model, basically, we're looking at just Java beans. In this case, there could be CDI annotated beans. There could be JPA entities, or supported by JPA entities. And then bean validation, right, is a way to apply constraints to your model. It's not, bean in and of itself, per se. But you've got a way to model your data using these technologies. On the view side, from Java EE, we have JSF and JSPs as kind of being the standard view technologies. So it doesn't mean there can't be others, right? There's a way to extend the model view controller framework to include other view technologies, right? By implementing, I think, a viewable class, right? And so if you wanted to, you could use, Tapestry or whatever, right, as your view technology. But just from a Java EE-centric perspective, we already have two view frameworks in Faceless and JSP, and so they'll both be supported. Faceless is the templating technology behind Java Server Faces. Okay. And the controller is just a JAX-RS resource, right? So, if we take this example, what you'll see is we have a class, basically a JAX-RS resource, hello controller, and you'll notice that on the GET request, what we're also doing is we're adding the annotation at controller, right? And that's just basically stating to the framework that this is the controller class in this MVC model. And so, in this case, because it's annotated with controller, and we're returning hello.jsp, the framework will see that because it's a controller, it'll interpret JSP as that it should take the output and push it to a JSP runtime, right, to actually do the rendering. So, I don't know if you saw, but we actually injected the model, which in this case is a greeting. This is the greeting class, which is basically get message and set message, right? Get the greeting and set the greeting. And, accidentally hit that. You'll see that it's annotated with that name, which means that this can be accessed from JSP and JSF. It's request scoped, right? The CDI request scope. And so now, if you take those two things and we go back, what you'll see is it just, because it's named, it can be accessed from JSP, and we're just applying the greeting within this JSP page. Pretty simple, right? But it's different from JSF. Okay, HTTP2. Anyone here doing any HTTP2 stuff? Yeah, I didn't think so. It was pretty much just ratified. Anyone doing Speedy? Oh, yeah, okay, yeah. So Google basically was behind Speedy, which really became the foundation for HTTP2. And the idea is, HTTP 1.1 has been around since 1999, and so it's time for an upgrade. The average page size has gotten a lot larger. The complexity of the pages have increased, right? So we need to kind of revamp the HTTP protocol to make it more performant, right? I think I was looking at a WebTide presentation where they said the average HTML page, I don't know where they got the average from, but basically it had 32 resources, right? Basically, if you count images, which are ads, images, pages, CSS, JSP files, like 38, right? And so what we need to do is basically reduce the latency, do anything that we can from a protocol perspective to increase performance and lower the latency of the protocol. So that's one goal. The other is to address the header line blocking problem, right? You can already multiplex over connection, but once you have a request out, you still got to wait for it to come back before the next request can go. Support parallelism, basically have multiple requests going simultaneously over one HTTP connection, right? And we want to retain the semantics of 1.1. So basically, what you do as developers don't have to change at all, and it's just going to work, even in HTTP 2 mode. Okay. And define interaction with HTTP 1. If any of you were here for the WebSockets presentation I did, was it last year? And I apologize if I keep stepping in your way.
I'll get this.
Okay, you get the slides. So basically, WebSockets use the HTTP 1 upgrade protocol. So HTTP 1.1 defines a way to take to begin as an HTTP protocol and then upgrade to something else, right? And WebSockets does that. And basically, HTTP 2 does the same thing. It begins as an HTTP 1 connection, and then if the server and the client both support HTTP 2, they'll negotiate and upgrade to HTTP 2, right? So when you're doing development and you use Telnet or whatever your client is, or your web browser, and you want to see all the gets and puts and stuff going back and forth, you can do that. But then as soon as you go to HTTP 2 on both sides, it becomes a binary protocol, right? So, and it's the binary protocol that enables a lot of this. So basically, it has a framing mechanism, right? And really, what you're sending back and forth aren't entire strings of information. You're sending binary frames. And it's fully bidirectional, kind of like WebSockets. And it can have multiple streams. And I can assign priorities to these streams going across this connection. So for example, I might want to say, as a developer, make sure I push down the CSS before I push down the HTML, right? And I can do it both. I can do many things in parallel, but I still want to prioritize what gets down to the client first. There's also something like something called server push, where to fully render the page as a developer, we know these are all the artifacts that we're going to need. So instead of having the browser make a request, get the data, then the browser figures out, okay, I now need this image, and then it's going to go get this image. You can basically, the server can start pushing, send down multiple push requests to the client without the client having to ask, right? So the idea is reduce the latency. I mentioned binary framing, header compression. So header compression basically says, with HTTP 1.1, every time you send a request, you're basically sending this long header, even if the contents of that header haven't changed, right? You still have to send it with each request. And what header compression does is, you have your initial connection from 1.1 to 2. Now you're in 2. And so what it's going to do is only send the headers that are going to change from request to request. So once you send, for example, compression zip or whatever, it just does it once, and everything else going across is going to come down. Any other request is also going to automatically be zipped, right? Stuff like that. So again, it's less processing on the server side to process headers, more time actually doing business logic. Okay, so that was kind of a brief introduction to HTTP 2. Now, the way we're going to implement HTTP 2 is going to be in Servlet 4.0. Okay, so the interesting thing is, in the Servlet API, everything is request response, right? So we're going to basically add the ability for the servlet to understand the difference between HTTP 1 and HTTP 2 message, because you have to deal with multiplexing. You want to know which stream you're on. Stream prioritization. So we're going to add basically an API call to the servlet API so that the developers can define the priority of the streams, right? Server push is something that we'll add to the servlet 4.0 API so that you can proactively push down content to the client. It doesn't have to ask for it. The binary framing is, we're not going to do anything from a servlet API perspective in terms of dealing with the binary framing. For example, I think you might be able to change the size of the frames and stuff like that. But we're not going to do that, at least not in servlet 4.0, right? Maybe it'll show up in a later version of the spec. And then, of course, it's going to use HTTP. We have to provide the HTTP 1 capability to upgrade from 1 to 2. Right? And that framework is already there because of WebSockets and Java EE7, so it should be pretty trivial to do that. Okay, JAX-RS 2.1. I think I'll make this the last before the break. Okay, we'll see if the room clears out. Yeah, see if it's interesting. Okay, so the big, well, JAX-RS in and of itself is a pretty feature-rich spec, and I think it's probably these days the most popular spec out there in terms of how developers write code. So from a performance perspective, they're looking at adding a reactive API. So if you look at JAX-RS 2.0, we added an asynchronous support. Right, so you can basically, from a client side and a server side, send and receive calls in an asynchronous manner. And now we're going to be adding non-blocking support, right? So if you look at servlets now have non-blocking support, meaning that when I, as a server container, if I'm listening, or actually as an app running on a server container, I don't have to just block on a read. I can actually just say, give me more data when it's available. And it'll tell you how many bytes are available, and then you can process it, right? So if you look at these things, what people are wanting to do is take advantage of the NIO support and the asynchronous support and provide an easier-to-use, higher-level protocol to make that easier to use, right? Because whenever you're dealing with asynchronous, then you have to deal with the order of operations, and you have to get all this data back from all these asynchronous connections, kind of find a way to aggregate it together and do something with it. And so they're looking at ways of creating a reactive programming model, interestingly enough, using the Streams API to do that. And so there's a very interesting, if you go to, you can watch all the Java 1 presentations online, right? And Merrick, the spec lead, did a presentation on this at Java 1 last year. I actually attended that session. And he shows this example of where you can basically use the Streams API to say, okay, go off to these 5 websites using async JAX-RS. When you get the data back, right, filter it, well, first filter it, do a map on it, and whatever. And at the end, you have your response that you want to send out to the client. I'm not really doing it justice, but it's actually pretty interesting. It makes building, reactive applications pretty interesting using JAX-RS. Java EE alignment. There's some gaps in alignment with JAX-RS and CDI that they want to fix. There is no security model really with JAX-RS the standard. The spec, I should say, in Java EE. I know Jersey's done some things that allow you to use roles allowed. Right? If someone's in a role, then let them consume this this method or call this method. What they want to do is create a declarative security model around JAX-RS. So you can define who can make what calls to which resources, right? And it's actually very flexible. I'm going to show you that in the next hour. Talk about MVC and JSON binding. So there is actually no standard way using JAX-RS to bind JSON objects to their Java counterparts, but the frameworks out there like Jersey and REST already do that, right? But they do it differently in a non-standard way. So that'll be kind of fixed in JAX-RS 2.1. And I think I'll leave it at that. So it's 8 o'clock. if you want to do that.
Okay.
And coming up, I think I'm going to talk about security and RESTful management and a few other things. So.
Very good. So let's go ahead and take a 10-minute break. As I said, the restrooms are in the back, and I'll let you know. There's probably a little more pizza left over. See you in about 10.